Trickling filter technology has been used for biological wastewater treatment for over 100 years. By utilizing an aerobic process, these systems remove organic matter and ammonium nitrogen from wastewater. The term trickling filter can often be misleading as no physical filtration occurs in these systems. In fact, trickling filters use structured sheet media as a host for microorganisms to grow and form biofilms. As the wastewater flows over the biofilm and comes into contact with the air, organic matter and nitrogen pollutants are removed from the water. Prior to the use of structured sheet media, rock was used in these filters to support biofilm growth. Many of these rock systems were constructed in the 1970s as a direct result of the Clean Water Act, which set new federal standards in the United States and forced many facilities to upgrade their treatment methods. The South Monmouth Regional Sewerage Authority in Wall Township, New Jersey, was no exception and incorporated riprap stone as part of its trickling filter process to support bacterial growth.
Here at the South Monmouth Regional Sewerage Authority, we employ a secondary treatment process. The process consists of pre-treatment through grit removal, then the flow goes on through a primary clarifier, then onto a primary trickling filter, then through an intermediate clarifier, onto a secondary trickling filter, then onto final clarifiers. Then the flow goes through post-aeration and a final settling pond before being discharged to the Atlantic Ocean.
The two trickling filters at South Monmouth are the largest on the United States East Coast, each spanning 184 feet wide, with a media depth of 7 feet. They performed well for many years, but in the late 1990s, deteriorating treatment efficiency and significant odor problems drove the team at South Monmouth to seek out a new solution. South Monmouth opted to maintain its two-stage trickling filter process by replacing the stone with plastic media. This PVC media has become the heart of any modern trickling filter because it provides the surface area to support ventilation and aerobic treatment.
After visiting numerous treatment plants throughout the world, it became apparent that the structured sheet media was the right technology to choose.
Following the installation of structured sheet media in 2001, the two retrofitted trickling filters at South Monmouth have enabled the plant to consistently meet discharge limits, and capacity has more than doubled.
We saw that the structured sheet media provided for much better treatment efficiencies. There was less maintenance associated with that media, and there were less odor complaints from surrounding communities.
Since trickling filters typically only require power for pumping, they use much less energy than other aerobic treatment processes. In fact, when designed and operated properly, trickling filters use 30 to 50% less power to remove the same amount of pollutants. They can also be combined with other processes, such as activated sludge, solids contact, or denitrification filters, to offer useful solutions that take advantage of both technologies. So while trickling filters may sometimes seem like old technology, there has been a resurgence in their use worldwide. The combination of modern engineering designs and inherent energy efficiency of trickling filters enable wastewater treatment plants to comply with strict limits and achieve high levels of treatment.